Welcome back to the Radan guys. This is Mike Brookman. I'm a technical sales specialist, and today we're going to be talking about importing DXFs. Let's dive in. Okay, now that we've got Radan open, we're going to start in part mode. There's a couple different ways we can work with DXFs, but we're going to start here, and we're going to go to open. We're going to switch to search for DXFs, and I'm going to open up this number 11, and I'm going to click open. Now, you'll notice it's got a lot of color that's associated with my part file that I brought in. And we can manage how we view this. So like this, if you have some parts that are being sent to you from a customer or from your own engineering team that has drafted these, perhaps they use colors and or layers to be able to distinguish some features on the part that they're trying to identify. So like this part, it's kind of got multiple things going on. It's got dashed lines, presumably to indicate bend lines. Like these might be up bends, that blue line might be a down bend. And then also has red that's indicating all of the external and internal cut features. This is going to be a problem inside Radan because we define a lot of things with color. Like on the cut features, we might have cut conditions assigned to a fast, medium, and slow cut based on the color of it. We might do something with etching or for open profiles based on the color. So you can certainly include the color, but that's going to be something that might give a behavior that you didn't expect. So that's going to be our first discussion point, is how do we get this to be something more like Radan's going to expect it. Okay, so let's bring in that part again. So we'll come up here to open. We got profile 11, and we're going to come down here to options this time. This options dialog box tells us basically a lot of information that we can control as we import these parts in. Now, the first thing we're going to do is we're going to jump right back here to mapping, and we're going to pop this open. So we're going to click on edit, and we're going to explain what's happening here, because this is what's making our part all the different colors that we see it. We're telling it to input any layer, any color, any line type. That's what we're searching for in our part. And then down here in the bottom, what are we converting it to? And at the moment, we're doing nothing different to it. More than likely, the most generic method is we're going to convert all pens to black, or if you had a black screen, it would be white. But we also want to leave the similar line types. That way we can keep these bend lines, because Radan, when it does its geometry check, it's going to ignore anything that's not a solid line. So we can leave those for identification down the road, and we can click OK here and OK. And now that's stored basically in our options as default. When I click on open now, it's going to bring that part in, and it's all black. Similarly, if we had done this when it was multicolor, we would have got the same results. But when we check geometry, it temporarily displaces those bend lines, and it's showing us internal features are purple and the outside is yellow. If there was something that wasn't conducive to being closed geometry, like for example, if I had a solid line in my part like this, and then if I do check geometry, it's going to flag where those infractions are. So on the end of each of this line, it's not closed. So it's telling us there's a problem here at the end of that, and there's a problem at the end of this line. So that's why if we had made these lines solid, instead of converting it to a similar line type, all of these would then have to be removed from our part because they're not closed entities, which we still could do. We could remove those and then carry on. But I think this is fine. It's just information, and we can continue. Okay, now that we're back bringing in a part, we're looking at this options dialog again. The first part of this under drawing tab is telling the software that the part I'm bringing in was drawn 1-to-1 scale. And it's telling it the drawing units or in inches. This is also important because if the part file that we're bringing in was drawn in, we'll say, millimeters, and we're in an inch environment, the part's going to be enormous. So this is important that you match what you're bringing in. So if you're getting customer files sent to you and customer B draws everything in inches and you're in an inch environment and this is set to inches, you're golden. If you work for customer C and they draft things in millimeters and they send parts to you, you're going to have to make some concessions for that. So here we'll just switch this to millimeters, indicating that the part files we're importing, even though we're working in an inch environment, it'll do the conversion for us. So it's still a 1-to-1 scale. Millimeters, what the import file was drawn in, and as it comes into Radan, it'll be converted correctly into an inch environment. Conversion. This is our attempt to be able to strip away some information that may be on the file that we don't need. So if we look at this more as a DWG versus a DXF, DWGs sometimes carry more of that technical information. Like you might have notes, might have a title block, might have dimensions. It may have other views of the part than just the geometry of the part. So if we can kind of try to strip some of this away by saying convert lines and arcs only, maybe just to DXF points, dimensions to drafting dimensions. Some of these things here could remove some of that erroneous information that we don't need. We're trying to just get down to the part geometry. Another great utility is this bit down here where it says smooth data. Under the advanced tab, there's several things that we're searching for. Basically what this boils down to is it's going to kind of cure poor drafting skills, right? So if it had overlaps or gaps, if it had duplication of features, it's going to try to change. If it was drawn in ellipses, it's trying to keep that same trajectory, but try to make it in fewer lines and arcs. Instead of thousands, it might be hundreds or maybe tens. So it's trying to simplify the geometry that's there to, like, especially if you have a laser, to try to prevent many, many lines it has to read and make it a little bit smoother for the machine to run. However, this is very powerful. So if we had features on our part, like we do in this DXF that we're looking at, this profile number 11, I don't know exactly what size those holes are without measuring, but I'm just going to take a guess that if we say a tolerance of 1 inch, that's going to have an impact on the part. If I click OK on that, then I also then just re-import that part. Notice I don't have any holes and I have some weird geometry going on over here because it's trying to filter out things that are less than an inch. So be cautious when you engage with this, that it may have some impact on it that you weren't quite expecting. It's oftentimes you come back in here and check and like, oh yeah, I forgot to put, I really meant to have 10,000s or something like that. We're going to keep it at 5. That's kind of the default, just to kind of clean things up. Mapping, we've talked about this once, but we can also include multiple lines in this. So for example, if we added a line and we're telling it, okay, we're searching, but we come across a color that we want to keep, but from the drafting side, the input file, it might be drawn in red. So we'll say, if you see something in red, I want to change that to blue, maybe. So this can be included, and we'll just say, yeah. So it's going to read this from top to bottom, like a lot of things that happen in Radan. When you have a file, it reads it from the top to bottom, and then it comes back to the top and starts to applying the results. So if we change red lines to 5, it'll know that, and it'll keep that intact, as well as then changing everything else we have that's not been changed previously to black. So if we had a file like that, it could represent it, but take my word for it, this will happen just fine. If we go back in here to edit this, let's say that it wasn't a default color that we have in here. So then we would select number, and then you would just match whatever color the draftsman used. So if it was color 165, whatever is drawn in 165, then we could convert to a more nominal color in Radan, making it pen 5 or blue. Converting layers is something that's very difficult to be able to manage. It's very specific. How you would achieve this is you would convert all layers is what we want. If you were trying to be restrictive as far as importing, removing information that was drawn on layers, there again, it's going to have to be very restrictive. So if you had something that was like on dim 0 versus dim 0 or even dim 0. So all of that to us would mean the same thing, but this is that restrictive where it has to be case specific and also space specific. So if this was, all caps with a space and then 0, you're good. All caps, space and 0, this one wouldn't work because it's not exactly like the layer that's on the part. Therefore, this is probably reserved for companies that have a very good relationship with the people doing the programming and the people that are doing the drafting. To get around that, you can create templates. So back when we were talking about inch and metric, if you have things that are drawn in inch, so if I select inch, if I go to options, notice that's 1-to-1 inches, similar to what we saw as my default. If I go to millimeter and go to options, now I'm using a 1-to-1 scale, but bringing it in, stating that my input file was in metric or in millimeters. This is also true if you had something similar to what we were just looking at with layers. Say if you have a company that you were working exclusively with 2 or 3 designers, well, they don't necessarily follow the same rules. You can create templates then for each designer. So if you had a John, a Paul, and a Tim, you can set that all up for Tim's method, Paul's method, etc. Okay, the last option that we're going to talk about in part mode for DXFs is going to be this option here. When we have a margin set to none versus custom. So if I switch this, we'll start with none. Now, notice I'm opening this up directly into part mode. In Radan, we have 2D CAD and we also have part mode, which do nearly the same thing. Part mode is just a little bit lighter weight than what 2D CAD is. 2D CAD, if we switch to this, notice my part then is pressed all the way to the extent of my viewing window. If I make my window bigger, it makes the part bigger. There's no getting around that. And that's where that margin is coming into play. But this is a great tool to use because now I have the ability to see layers. So if it wasn't active, if this was off, if I click patterns, is what we call layers in Radan, this could be used to be able to identify any layers that this was drawn on. So as you can see, the only layer that's present on this part is 0. So that kind of comes back to this option here. When we're trying to convert things by layer, you'd have to have 0 listed here for anything to come in. As you can see, I have NC Geo and Radan. Neither of those exist on my part, so if I import this again, nothing would appear. If I was being as restrictive as this, instead of convert all layers. If we go back to this example here for a minute, so I'm going to go to new. Well, before I do that, the main reason that we would bring something into 2D CAD versus part mode, and there again, you could do this in part mode also, but it kind of gives you 2 windows to use doing it this way. It would be a multi-part DXF. That's pretty common. I used to do this when I was a programmer, probably like you. I'd get files sent from a customer, and they would have a big DXF that would have all the parts that they wanted by design, and then underneath it might say what kind of material it was and how many they wanted. And so I could switch over here to part, go back to this little guy, this hand, say grab part from drawing, and then I could window this and have it go into part mode, and I could add in that information that they gave me. But notice the problem with that was I can't get it all because of that margin. It's pressed out to the extents of my window, and I can't window the whole thing. So if we go back to new, and if we go to open, we'll do it in 2D CAD. And if we open up number 11 once more, we change our options here to custom, and we'll maybe put a 5-inch border around the whole thing. And now if we open this, we'll say no to that. Now we've got some room to play here. So when I do this maneuver, go to part, go to the hand, window my entire part, I can push it over to part mode, and now I can save it as a Radan part file or an SYM with all the relative information I need. So I can give it a name, material type, and thickness, and save it. And then I can go back to my file. Just keep going back and forth until I had no parts left. These two buttons right here allow for that. So if I had two files, I would set this to cut, or multiple files. We'd have this set to cut, grab, part. So now if I go back to 2D CAD, after I save this, I shouldn't have anything left in my 2D CAD. So that's kind of like an excavate through a multi-part DXF. Okay, that kind of brings us to a wrap with what I wanted to talk about in part mode. We go now to nest. All right, so now that we're in nest mode, there's two different ways we can bring in parts into a project list from Radan directly. We can bring in Radan part files, or we can bring in DXFs. I'm going to choose DXFs today. Notice I've got an import window back here, and it's already preloaded the last position that you were on your network to bring in parts. So I'm just going to grab a few. This options is the same options that we were working with in part mode. It's the same choices, same functionality, and we're just going to click OK and open these up. They're going to be presented in this window. They're all going to be selected once they come in, which is great because now, since DXFs don't have material-specific information, I can add that. So I can tell it, yep, all of these are mild steel, 060, and I'm going to click OK. Additionally, I can say I want 15 of these and apply. Now all of them are updated with a quantity of 15. If I choose them individually, I can see then a thumbnail how the part looks like. And then I can also say, yep, on this one, we only needed to have 10. And on maybe the left support, there's one in here called left strut. Did we grab him? Nah, it doesn't matter. There it is. We also need 10 to him. I can also individually change anything specific about this in this import window. So I can change the orientations of how it can be nested, if it's a candidate for command line cutting, etc. The last thing I need to have is a place where I'm going to convert these from a DXF into a Radan part file. So all of these have that included from when I imported them in. And so here's my output folder here. I'm just going to say import all, and they're all going to come into my project list for nesting. Okay, I'm going to go ahead and nest them up. And I'm going to talk about one concern, and that importing these DXFs, that's probably something you would do more regularly, is coming right directly into a project than doing them individually, like how we started with part mode. But that's either way is going to be fine. So if I look at one of these parts, we'll just say this. Boy, from earlier today, my part spacing is really big. But I'm going to say that this guy up here, something was mixed up with it, and I either have the wrong part or I need to edit something on this part. So I'm going to go to part mode, and I'm going to bring up that part. Okay, maybe I'm going to add a hole. We're going to put like a 1-inch hole right there. I'm not being very accurate, and that's fine. And then I'm going to save it. But just before I save this, I want you to see where this save datum is. Remember when I imported these in, I had margin set to 5555. So it's making basically a 5-inch border around my entire part. My save datum positions I can do traditionally are going to be bottom left, bottom right, top left, top right, and then the centroid. I can do user defined, but I have to have a user defined position first for that to be active. So once I save this, it's going to snap to one of these choices. If I save it, I'll say yes. And now it's snapped up to the bottom left corner. Now this is going to cause a problem because when I go back to my nest, all of my parts will be shifted on every single nest that part has been on, because the nester positions the parts off of that save datum. So that's why we prefer that if you're bringing parts in, you use that margin at 0 or no margin. So that's one concern. If you ever have to make an edit or a change to the symbol file that you created from importing a DXF, you may have this consequence. This is easy to fix. I just need to delete the nest or delete all the nests that part was on, and then just renest it. And if you already had made this all the way through code, it doesn't change the code output. It just changes the display. So if you had to rerun this for code generation, which we do because we put a hole in our part, we would have to renest this part. Well, I'm about out of tricks on showing you how to import DXFs. Hopefully that was useful, and you guys can put some of that stuff to work. This has been Mike with the Radan guys. If you like what you see here, guys, please consider subscribing. It's always nice to see that subscriber count go up. It's free. Why not continue? That way you won't forget the next time we release something, you can go ahead and watch it. We'll see you guys next time.